Okay, so we're going to do one final example here. This is actually a pretty complex one. So kind of the hardest part of this for me is going to be whiteboard management because this is going to be quite long. It's going to involve some nested subderivations. And like I said, it's important to keep your derivation neat. So we're trying to go from, it's not the case that P is equivalent to Q, to showing that either P and not Q or not P and Q. And that actually kind of follows just by definition, because we're trying to show that if these two things are not equivalent to one another, it must be the case that we have one without the other. All right? So how are we going to do this? Well, it doesn't seem like there's any direct route. So we're just going to go ahead and we're going to assume the negation of what it is that we're trying to prove, which is going to be a pretty long assumption, but and again, we're assuming this for purposes of negation elimination. We want to show that assuming that this is not true, given this, is going to get us into some kind of problem. And so we're going to have to drop the negation sign. Okay, so now how to proceed. So what kind of contradiction can we get in here? Well, we can either try working forward from this to get this again. I don't think that's going to work in this case. We can try showing that given this assumption, this must be true. P is equivalent to Q, which would contradict our line 1 here. So let's try working towards that. Okay, so we're going to get this line, we're going to get our bottom line, our goal here, by negation elimination. This line here, we're going to get it by biconditional introduction, obviously, because the main connected is a biconditional. And that means that we need to make two subderivations, one beginning with P and ending in Q. And one beginning with Q and ending with P. So our line 3 here, this is an assumption for purposes of biconditional introduction. All right, so how can we get Q from P? Well, it doesn't seem like there's any obvious way given what we have. I mean, these are both negations, so we really can't do much with them, and it's not we're not going to get Q just directly out of P. So we need to make yet another assumption here. We're going to assume not Q and see if on the assumption of P, not Q will get us into some kind of contradiction. So not Q is being assumed for purposes of negation elimination. All right. So what can we do now to get a contradiction? Well, we have P and we have not Q. if we put that together, we have half of this disjunction, okay? So conjunction introduction on lines 3 and 4. So think about how we can get a contradiction now. Remember the rule of disjunction introduction? We can take any sentence, put it in a disjunction, and make that into a disjunction with any other sentence. In particular, we can take P and not Q and make it into P and not Q or not P and Q, right? And we're doing that by disjunction introduction on line 5. Now, on line 6, remember we're trying to get a contradiction in here so we can use the negation elimination rule. We're going to reiterate line 2 down here and set it so it's next to our line 6, and we can show that we have a contradiction. That's reiteration from line 2, and so now we have two opposite things together in this sub derivation that we have going here. Okay, so based on this contradiction, we know that this cannot be the case, at least on the assumption that P. So if P, then Q. So we got Q by negation elimination on lines 4 through 7. Okay, so we need to do that again down here in order to establish the biconditional that we want. And again, it might be a good idea to like pause this video at this point and see if you can reason through this, which is exactly parallel to this here. Okay, so this will be our line 9. It's the assumption of Q for purposes of biconditional introduction. All right, line 10. We're going to assume that not P for purposes of negation elimination. All right, it should be pretty obvious where this is going now. Or line 11, we're going to put not P and Q together with the conjunction. Okay, now we're going to use disjunction introduction again to get the opposite of this, in other words, to get this. Okay, and notice, disjunction introduction, of course, you can put it on the, you can add your new thing on the left or you can add it on the right. Okay, it doesn't really matter. All right, so here you can see I didn't leave myself enough room. So I'm going to have to shrink this P a little bit. Make this line come down a little bit more so I can reiterate this negation down to here. So again, that's reiteration from line 2. And we've shown that we have two contradictory things side by side here, right? So on the assumption that Q, the assumption that not P gets us into a contradiction. So if Q, then P, right? So we have P here on line 14 by negation elimination, lines 10 through 13. Okay, so now we're able to conclude line 15. We should move this up here so it lines up a little bit more with that. We're able to conclude that P is equivalent to Q on this assumption, right? Notice we're still inside of this subderivation. P is equivalent to Q based on lines 3 through 8 and 9 through 14. Okay. Now we're going to reiterate line 1 down here to show where the contradiction is. And now we're ready to finish this up with line 17 is going to be negation elimination, lines 2 through 16. So almost this entire proof, was this subderivation. And